The normal distribution. We have already looked at the mean, the median, the mode, the range, and the standard deviation, which are all measures of data and where the center is and how spread out the data is. We've looked at symmetric mound-shaped distributions. If you want to go back and look at that on page 50 in your video guides, it's a great idea. We have used the empirical rule, which is also on that same page, to look at symmetric mound-shaped distributions and talk about the percent of data that we expect to be in each region, a certain number of standard deviations above or below the mean. And we have drawn mound-shaped distributions and figured out percentages of what percent of data we expect to be in each region. And then finally, we looked at percentiles and box plots. Well, using the information that we have, the empirical rule, which gives you a rule of thumb for what percent of data is in a region, and the mean, median, mode, range, and standard deviation, we're going to put all of those to use and do some real statistics. We're talking about the normal distribution, and here is an example of a frequency distribution for the heights of 150 random men. We have classes, remember those classes, 4.5 feet to 5 feet, 5 feet to 5.5 feet, 5.5 to 6, and so on. And then we have the frequency. So how many people, how many of the 150 men fit into each of these height classes? If we graph that as a histogram, we get a histogram like this, and it looks pretty much like a mound. This bar is a little bit high and this bar is a little bit low, but other than that, it's pretty much got that mound shape that we were looking at. And what I want you to know is that right now it looks pretty rough and pretty chunky, blocky, if you will, but it still is roughly symmetric about the mean. So about the middle here, we see a rough symmetry. So if we take that histogram and fold it on itself, the left half and the right half should be about the same. And as your data set gets bigger and bigger, you take a larger and larger sample, then you get more and more data, and you end up needing to shrink these classes a little bit so that you can still be really representative of your data. Every time you shrink the classes, you have more and more and more classes on there, and the bars end up getting closer and closer together, and they're a little bit chunky, but they get, the bigger your data set gets, the closer you get to a nice smooth mound, because you have tons of little divisions in here for each of the classes, but they're so close together that your eye just sees a nice smooth curve. So this we call a normal distribution. And if we were to sample the heights of all men, which would be a population, so if we took our population data for all men and put it into a distribution, that would be a lot of men, and it would look pretty smooth and mound-shaped like this distribution here. So you can see that I also put on this distribution, it's a relative frequency distribution, and I put the population formulas here and the sample formulas here. And remember, the center is the mean, which is mu for a population, x bar for a sample, and then you go up 1 standard deviation or down, up 2 standard deviations or down 2, up 3 standard deviations or down 3, and that gives us markers for where our data is. The other thing that we know is that there's only one mode for this data, and it'll be right here at the center. So if you have bimodal data or many modes in your data, it can't have a normal distribution, because we're saying some characteristics of a normal distribution are it's bell-shaped. We talked about that. It has a nice smooth curve, and it has a mode, only one mode that's at the center. The shape is symmetrical about the center, like we are talking about. If we fold right here on this line in the middle and fold the left half onto the right half, you will see that they match up very nearly exactly. And another thing we know is that the mean, median, and mode are pretty much the same. They're very close together right here at the center, and we've talked about that when we talked about skewness of the data, and that if you have mean, median, and mode all within 1, unit of each other, then you probably have a mound-shaped distribution, or in this case, we're talking about a more specific mound shape, which is a normal distribution. Another thing is the total area under the curve is 1. So if I'm looking at all of this area, remember how we were drawing in the areas before of what we were interested in that would answer our question? Well, here we're saying this entire area, all of this, and including all the way over here, all of that together totals 1. So we have a full area of 1 for the entire curve. And then the distribution, the shape, is completely defined by the data's mean and standard deviation. And we can see that here is where you need the mean, and then you either add or subtract off standard deviations to help define all the different bars on there. So that's all you need for from your data to draw a distribution like this, is a mean and a standard deviation.